Hello, hello, my quantitative analysis party people. So, this week we are doing chapter 5, I believe, on variability. So, I wanted to do a video that explains just sort of basics about variability in words so you can hear it explained to you instead of only just reading about it, but then also show you how to calculate the standard deviation and variance by hand, which is what you'll be doing in your third lab. So, variability is basically just how much do the scores in our data set vary from one another. So, in one variable, how much do people differ? Are they really similar to each other? Are they really different? We also talk about this as spread or dispersion. So, one really cool thing about variance and standard deviation in particular is that these descriptive statistics basically undergird all of the different forms of analyses that we use. So when we're doing a correlation, we're essentially looking at some form or derivative almost of variance. And the same is true for ANOVA, or analysis of variance. And then the same is true for regression. For all these different complex statistics that we're doing, if you look at the math behind it, all we're really playing with is variance in different ways. Maybe we're multiplying it by the variance of another variable, or all these different sort of mathematical tricks that we do essentially just to the variance. So you don't need to worry about all that right now, but that's why this is such an important concept in addition to just being a descriptive statistic about our data. All right, so let's look at variability visually. Let's imagine we got some scores from people on their agreeableness. Maybe you've heard of agreeableness before. This is a personality trait, which is a tendency to be likable or friendly. It's those people who are very warm and they get along well with others. Those people are high on agreeableness. And you have your grouches who are low on agreeableness over here. So let's imagine we got a bunch of people's scores, that's what's in red, on their agreeableness. Somewhere 3 point something to a little over 5. We have 4 people's scores. And what we can see from these scores is that they're kind of all clustered pretty similarly. They're all sort of next to each other on our full range of this spectrum. We don't really have our grouches, and we don't really have our super friendly golden lab type people over here. They're just sort of similar to each other. And so here we have low variability in this particular sample. Let's imagine we also got a different sample, and these people's scores are represented in green. So we have a grouch kind of person, not very friendly, a little prickly, and we have our golden lab over here and kind of everything else in between. So here in sample 2, we have a lot more variability. People are a lot more different from each other in this particular sampling of people, these 4 people that we looked at. So that's essentially the basics of what we're talking about here. So there are 3 measures of variability that are commonly used. We have the range, we have standard deviation, and we have variance. And usually when we are reading a study, someone's research report, basically, there are the average is reported, and then the variability is often reported. And usually the average tends to be the mean, especially, as you learned, if we're dealing with an interval or a ratio variable. And then the variability that people report is usually a standard deviation. So when we are looking at standard deviation, we're representing it by an SD or an S most commonly. This represents essentially the average amount of variability in a set of scores. So I'll unpack more about what each of these things means in this equation. It's a little weird looking at first. You have this big square root and you have this weird backwards E thing and an X bar. It's just a little foreign when you first see it. But don't worry, you'll get more used to looking at this and stuff like this the more you learn about quantitative analysis. The main idea here is that we're looking at the average amount of variability in a set of scores on a particular variable. So this is just for one variable. And the reason why we know it's an average is because we're essentially taking the average here. We have n, which is the sample size. So we want to know everyone's variability score, and then we're dividing it by about how many people we have. We have n minus 1 because we're doing an unbiased estimate, and we need to correct for the fact that this is a statistic for our sample and we are making an inference about the population. So we just subtract by 1 to inflate the standard deviation and give us a better idea of the population statistic. But don't worry too much about that right now. The main idea here is that this is an average. So as I noted, the S is the standard deviation, or SD, and then we have this backwards E looking thing, which is sigma. And sigma tells you to sum whatever it is that comes after sigma. So then we have, after sigma, we have this parentheses x minus x bar squared. So everything with the parentheses to this squared, that's what we're summing. Now let's talk about what it is that we're summing. So x refers to each individual score. We also refer to this as x sub I, which I will talk about a little more later. X sub I is a more technical way of writing this, but sometimes we just refer to it as X. It just means each person's individual score. And then X bar refers to the mean. Sometimes we write it out as X bar, sometimes we get fancy and we put a little bar up there, but it's hard, you gotta go look around for the bar in Excel. So sometimes it's just X bar written out, but it's the mean of all the scores in the sample. So going back to our equation, everybody in our sample on this variable X is going to have the same mean because a mean is a descriptive statistic for a sample. But they're all going to have their own X scores. And so that's where this summing thing comes in, the sigma, because every person has their own deviation score, their own squared deviation score. And this will make a little more sense when I show you the lab. And then lastly, n is the sample size. All right, so let's go back to our example with our 4 people, and now we know their scores, 3.4 to 5.1. This is our low variability sample. These scores are our x sub I, or just x. So what x sub I says is, look at x and then look at the ith position in x. So x is a list, right? Or in our R terminology, it's a vector, I guess. So x has 3.4 as a value, 3.8 as a value, then 4.3, then 5.1. All these values in a row for different people. And the I says, look at each individual in your variable x. And what we really have here, if we break it down, is x sub 1 means look into x, that's agreeableness, and look at the first person in our vector. That's their score is 3.4. Now if you go to x and you look at the second person in our vector, you have 3.8. The third person in a vector, you have 4.3. And then the fourth person, you have 5.1. And so the I just says we're looking at all of those people. That's what that symbol means. Okay. So now I'm going to show you about how to do the standard deviation by hand. We'll get to this later. So I'm taking with our writing example, I'm taking this 3.4, everybody's score, 3.4, 3.8, 4.3, 5.1, and we're going to calculate the standard deviation for all those scores by hand. So I just put them over here in step 1 where it says x sub I. Now let's go back to our equation and look at that while we're doing this example. So we just need to figure out everything in this equation and then plug it all together correctly, and that'll give us our standard deviation. So in step 1, we're just listing all the values for x, more technically x sub I. Now we need to figure out the mean for our sample. And I'll show you how to do all this in Excel. It's a lot easier to do this in Excel if you know a little bit about it. I'll show you some of the stuff that will make this easier. But you're welcome to also just get a pencil and paper and a calculator and do all this by hand if that's something you prefer. I'd encourage you to try using Excel because it's an extremely important skill to have when you go out looking for a job. So I'll show you some stuff here that might help if you're not familiar with it. So we need to find our mean. If you highlight a bunch of numbers in Excel, it will show you down there the mean. In this case, they're calling it the average, but it's the mean. It'll tell you the count as well. It'll also tell you the sum, but we're interested in the mean, so that's 4.15. And then if you want to copy a value across different cells, it's pretty easy. You just copy it, select the cells where you want to copy this value to, and then paste. And so in step 2, everybody has the same mean because that's the sample descriptive statistic, sample level. There aren't different means for different people. They're all the same. Okay, there we go. Step 2, we have X bar. Now we need to find what is called the deviation score for people. So in the deviation score, we're basically looking at how much each individual varies from the mean. So some people it'll be negative, some people it'll be positive. This person will be negative, that person will be positive. In Excel, we'll do this by writing a little formula in these cell files or these cells. And you always have to start a formula with an enter. So we'll enter our x sub I minus x bar. Okay, so we have this negative deviation score for the first person, just as we thought we would. Then when you want to copy a formula to different cells, it's pretty easy. You just put your crosshairs over where you originally wrote it and then just drag it down. And what this did was it took the same formula but it applied it to this lower row. So it didn't just keep it up there, it moved it down there for you. And same there. You could just copy the first one and then paste it and it'll do the same thing. And again, it'll move the values down by one row for you. So that's our deviation score in step 3. So now we have this for each individual person. We'll have to square it first though. before we sum everything. So to square it, we'll just do our equal sign again, click on our cell, caret for squaring, and then 2. And we'll just drag it down again. Okay, great. Now we have step 4. We have these squared deviation scores for each individual person. Now in step 5, that's where our sigma comes in. We're going to sum all of these squared deviation scores for each person. So we'll sum the results from step 4. To sum in Excel, you just type sum and put your parentheses and then drag down, close the parentheses, and enter. So then I added this kind of step 5.5 because it's not written as a step in your book, but we still need it to figure out every component of our standard deviation. So I have n minus 1. N is our sample size. We have to subtract 1. We'll just count 1, 2, 3, 4 people in our sample. Minus 1. That's 3. All right, now for step 6, we're essentially calculating the variance on the way to calculating the standard deviation. Anytime you calculate standard deviation, you're technically calculating the variance as a step towards the standard deviation. And that is because if we look at our formula again, we have the square root of the variance. So let's look at our variance. This S squared is our variance symbol, one of the many variance symbols. And it's the same formula, but without that square root. So they're connected together. Okay. So let's go back here. So for the variance, we know this top part. That's what we did up here. And now we know the bottom part too of our fraction. That's what's down there. So it's pretty easy at this point. We'll just take the numerator, divide it by the denominator, and that's our variance. I will show you as well how to check your work in R. So I want you to do this by hand, and basically in undergraduate stats class, you're going to calculate standard deviation by hand. And the reason is because we want you to see what is going on here to better understand this formula, these two formulas basically. And in reality, when you're doing your own analyses, there's very easy ways to calculate the variance and the standard deviation that are in your book. It just takes one line, but we want you to know how to do it by hand so that you understand what's going on, because as I mentioned, these are extremely fundamental concepts in statistics. So if you go to grad school later on, or if you work analyzing data, then you're going to be thinking about these concepts quite a bit. Okay, so that's my little tangent there, but let's figure out how to, check our work in R with the variance. If we want to, we're going to make X in R, copy all these values, go to R, and we're going to make a vector like we've been doing. And so I pasted all our values, but it doesn't have the commas. So I go and I add our commas. Interestingly, if you leave them stacked like that, R doesn't actually care. It'll be fine. It'll make your vector here. And you see it down there. There's a lot of other stuff, sorry. Normally we have it like that. This isn't one of the things that R is fussy about. You can stack your code if you want. So it's just I don't know, a quirk of R, I guess. Okay, so we have our vector. Now let's find the variance of x. Ah, perfect. 0.53, 0.53. And it's just so interesting because here we have, it's such a simple line to get all that, the number that we worked so hard for, the variance that we worked so hard for in this section over here. That's why R is awesome. Okay, so now we have the variance, and let's go back to our equation. We're going to take the square root of the variance as our last step to get the standard deviation. So the square root function is sqrt, and then plop in your number there, close parentheses, enter, boom, standard deviation. Now let's check our work. We'll go back to R. And it's the same number, 0.73. So, and I tell you about this, not because I want you to just do task 1 in R in your lab. I want you to do it by hand so that you learn what's going on here. But you can check how to do it in R to make sure that you got it correct. Okay, now the last thing is to remember to round. So we'll round to our second decimal place. So we look at our third decimal place, there's a 6. When we round it to the second decimal place, it will be, we'll have to go up by 1, 0.54. And then for the next one, 7.32. 2 is below 5, so we don't need to go up. And you don't really need to round in these intermediary steps. You can if you want, but the rounding is more of like a rough estimate. It's more of just a convention for displaying numbers than for getting the exact correct number. So just make sure at least you round at the end. So that is how you calculate the standard deviation by hand. And let me know if you have any questions. Come to our RHacker lab meeting if you have some questions, or schedule a one-on-one with me. I'm happy to talk with students for things that come up. Your book should help with a lot of this, and hopefully this video does as well. But please feel free to reach out if you have more questions that aren't answered there. All right, good luck.